Okay, we're going to just take a look at the activity that we did around vertex form for our quadratic. So we've looked at factor form, and we've looked at sort of when it's just an expanded form, parabola or equation. Now we're going to take a look at when we have an equation in factor form. Okay? So we have this form where we go in brackets x minus a all squared plus b. So it's still a quadratic, and it is written what we call in vertex or transformational form, because it's a very nice way of looking at looking at how we move and shift the graph around. So if we just go into that activity and we take a look at what we've done, just to reinforce what we've done with this kind of snapshot of it. So we have the equation x minus 2 all squared plus 1. Now we'll take a look at this graph. This is, Desmos has graphed this, and we need to find the vertex. Well, the vertex is a minimum point at 2 and 1. Okay? Now if you look at the equation and you look at the vertex, you should see that there's a bit of a pattern or a bit of an association with that. Now if I was to write another equation in vertex form, let's go x plus 3 squared, and let's go minus 2. Now look at those numbers and then look at where new vertex is. Vertex of the first one against the equation, vertex of the second one against the equation. Now let's do a little bit more of an investigation and go to the next slide. Now what we've done is we've put the x plus some number, we've used an a instead of an actual number squared, and that creates us a slider. So when we change that number inside the bracket, look what happens. Only changing the number inside the bracket. So that number inside the bracket that is either added or minused to the x inside the square bracket moves the graph right or left. So now the next thing is, what is the actual move? So let's just move -1. Okay, so from the original, remember the parent function is always starting at 0, 0. And if we move the slider to -1, look how the graph changes. It goes to the right one. If we go back to 0, 0, and we go to the right, or we go +1, sorry, then the graph moves to the left. So that number, if it's positive, moves the graph to the left of 0, and if it's negative, it moves it to the right, which is basically opposite to what we have. So the move is always opposite to what you have. If you have a +2, the move is to the right, left of 0. If you have a -2 or a -3, it's to the right of 0. So we've learned something about the point inside the bracket. So if we give x plus 3 all squared, what's the position of the vertex? Well, it's going to be at -3, 0. And if we have x is -2 all squared, then the vertex is going to be at 2, 0, because it's moved to the right. So here's a whole bunch of, this is y is equal to x squared, which is the parent function. And then we've gone x plus 2, we've moved it to the left, that's the blue one, and the orange one, x minus 3, is moved to the left 3. Now, we're going to take a look at what happens if we do b. So let's just move a to 0. Let's just ignore a and make it 0, okay? And let's just make b 0 for the moment. Okay, so we've got a vertex at 0, 0. Now, when I move b, what happens to the graph? The graph moves up and down. The vertex is being pushed up and down. So if I go to 0, and then I move it to +2, it goes up 2. If I move it to -2, it goes down 2. So that's not the opposite. That's what b is doing. and B is not the opposite, whereas when I moved A was a movement that took the graph in the opposite direction to what we would think. So positive takes it left, negative takes it right. B just moves it up and down. Okay, so these are all the different moves. We haven't changed the x squared in these. We've just changed the b to 4 and 3. So 4, the blue one, just goes up 4 from 0, 0, and the negative 3 just goes down 3. A quadratic in vertex form tells us how the vertex of the graph has shifted. So it's very useful because if you know where it shifted, then you can draw the rest of the graph. You just have to go over 1 up 1, over 1 up 3, over 1 up 5, and you can basically draw the entire graph in some points very, very quickly. It becomes very useful to know exactly where the vertex is being shifted. So the equation to the left has a vertex at what position? At -1 and -4. And let's just see. At -1 and -4. Okay, so in your notes or wherever, you need to know what A does to the graph and what B does to the graph, and you need to have some notes, and you need to be able to use that information for you to predict where a vertex is or to redraw an equation or whatever you need.